Question number 71. Which parameter is neglected in medium transmission line? Option A, shunt capacitor. Option B, series inductor. Option C, shunt conductance. Option D, series resistance. Question is asked in Mahatransco AE exam year 2022. We know that for short transmission line, we consider two parameters, that is series resistance and series inductance. For medium transmission line, we consider three parameters, that is series resistance, series inductance and shunt capacitance. Whereas for long transmission line, we consider all four parameters, that is series resistance and inductance and shunt capacitance and shunt conductance. Now in case of medium transmission line, we don't consider a shunt conductance. So this G we neglect here. So parameter neglected for medium transmission line is shunt conductance. The reason of neglecting shunt conductance in case of medium transmission line is that the length of medium transmission line is less than 200 km, and shunt conductance arises due to the flow of leakage current over a insulator, and this leakage current is less because medium transmission line having a small length less than 200 km and also the voltage level that is less than 100 kV. So therefore shunt conductance is neglected. So correct answer it will be option C. 72. The percentage bias for a generator protection lies between 5 to 10, 10 to 15, 15 to 20, none of the above. Now this question, it is on the generator differential protection. We use a differential protection in case of internal fault in a generator winding. Now we use percentage differential protection. So percentage differential protection, as you are aware, there will be two coils, restraining coil and a trip coil. So in order to prevent unnecessary tripping of the fault in case of external fault, we use a bias. Means we are asking the relay to not operate for a certain amount of current because that current may be due to the external fault or through fault. Now if you compare the percentage differential protection of a generator and a transformer, then in case of transformer we are aware that it is basically a voltage changing device. For example 400 by 220 kV or 220 by 132 kV and so on. So whenever there is change in the voltage ratio, therefore there are chances of a spill current even though fault take place outside the zone of protection of differential protection, and in order to avoid the unnecessary tripping we need to have more bias. So we keep 15 to 20% bias in case of transformer. But in case of generator, as there is no changing of the voltage level, we have 11 kV or 15 kV generator. So therefore here we can have a smaller bias. So usually we keep 5 to 10% bias in case of generator differential protection. So our correct answer it will be option A. So for transformer, chances of spill current during external fault is more, therefore we need to keep more percentage bias, or in other words we should have more restraining torque so that relay should not operate for external fault. In case of generator there is no change in the voltage level, therefore the chances of spill current are less, so small bias setting is sufficient. So we keep a setting of 5 to 10%. And what is the bias? Already we discussed in one of the video. It is a ratio of NR by NO, number of turns of restraining coil and number of turns of operating coil. So this ratio is known as a bias. Next question, question number 73, asked in Mahatransco Executive Engineer exam year 2024. The voltage that appeared across the circuit breaker contacts at the instant of arc being extinguished is called as arc voltage, recovery voltage, restriking voltage, surge voltage. Now understand, whenever circuit breaker contacts are closed, so these are the two contacts of a circuit breaker, simplified diagram I am drawing. One is fixed contact, another is the moving contact. Let us say this is moving contact, this one is fixed contact. So here circuit breaker is closed. Now theoretically how much will be the voltage across CB? It will be 0 because it's a closed condition, therefore no voltage will appear or voltage across breaker will be 0. This is the first scenario. Now in second scenario, circuit breaker has received the trip command from the relay, therefore its contacts fixed contact will remain in the same position, but moving contact has moved from its original position. So whenever this condition will happen, there will be presence of arc. So this is the arc. Now the voltage across the circuit breaker contacts during the arc, when arc is present, so this voltage is known as arc voltage. So voltage across the circuit breaker when arc persists across the breaker contact is called as the arc voltage. Now next, after some time or at the instant of arc being extinguished, means arc is not completely extinguished but it is about to extinguish the arc. So at that particular instant, a high voltage will appear across the circuit breaker, and that voltage is known as restriking voltage. So this voltage will try to restrike the arc once again. So this voltage that appears across the breaker contacts at the instant of arc being extinguished. Arc is not completely extinguished now, or there is no successful arc extinction, but just at the instant of arc being extinguished, the voltage that appears across the breaker is known as restriking voltage. Once this arc is completely extinguished, then the voltage that will appear across the breaker contacts is known as recovery voltage. So after arc is completely extinguished, the voltage appearing across the breaker contacts is called as recovery voltage. So difference between these two, here arc is being extinguished. Arc is not completely extinguished, but it is on the verge of arc extinction, and here arc is extinguished. So recovery voltage or normal system voltage will appear across the breaker contact. So here it is asked at the instant of arc being extinguished, so it is known as the restriking voltage. So different type of questions can be framed based on this particular scenario. So question number 74, asked in ESE exam, Engineering Services exam year 2022. Which one of the following is not a basic functional characteristic of protective relay? Now we know that for protective relay there are various desired characteristics, that is reliability, that is the necessary characteristics. So reliability means relay should be reliable. Whenever there is a fault, relay should operate, and when there is no fault, relay should not operate. So both these conditions will constitute the reliability. Next, sensitivity. So relay should be sensitive. For example, if you keep plug setting of relay as say 1 ampere, and if actual current becomes 1.1 ampere, then also immediately relay it should start operating, because the actual current is more than the plug setting. So even though more current is there than the set value, then also relay should operate, that is relay should be sensitive. So that is also a desired characteristic. The next, speed. Of course, speed of relay is very important, because if relay senses the fault quickly and if it gives the command to the breaker quickly, breaker will open very fast, and then fault clearing time it will reduce. So therefore, in order to have the smallest fault clearing time, or in order to have the more stability in the system, because stability is governed by the speed of operation. If you want our system to be stable, the speed of protective relay protection system, it should be fast. Therefore, speed of relay, it has to be fast. Linearity. So this is not the necessary functional characteristics of a relay. So linearity is not the correct characteristic. So here correct answer will be option D. So apart from this, another characteristic of relay, it is the selectivity. So what do you mean by selectivity of a relay? That relay should operate only if fault take place within its zone. If fault take place outside the zone, relay should not operate. So that is meaning of selectivity. For example, this is the system here like this. So here we are using breaker and associated relays, and here there is a breaker and associated relays. So let us say this is bus bar A, B and C. Now if fault take place here on feeder BC, so let us call this as relay RA and relay RB. So for this fault, RA should not operate, RB should operate, because this fault is within the jurisdiction of this particular protection system. And if RB fails to operate, then after some time RA will operate. It will act as the backup protection. So that is meaning of selectivity. That is also one of the important desired characteristic of relay. Another desired characteristic is the cost. Of course, cost of the protection system, it should be less. So these are the various desired characteristics: reliability, sensitivity, speed, selectivity, cost. Sometimes stability is also there. relay should be stable. So what do you mean by stability? If I explain from this figure itself, if fault take place here, high current will flow. It will flow through both the cities of feeder AB as well as feeder BC. But that high current, it should not lead to operation of this particular relay RE. First RB should operate. Okay, so relay should be stable. So that is the meaning of stability. All these are the desired characteristics. So linearity is not the desired characteristic. So correct answer here, it will be option D. Moving ahead, question number 75 asked in Mahatransco AE exam year 2022. ABCD parameters of medium transmission line for nominal pi method are. Now we know that for ABCD parameter of nominal pi method, so A is equal to D equal to 1 plus ZY by 2. Then B is equal to Z, and parameter C is equal to Y into bracket 1 plus ZY by 4. Try to remember this. Whether it is nominal T or nominal pi, A and D are always equal and its value is 1 plus ZY by 2. You need to remember these two parameters. So these are the parameters for nominal pi model. So here correct answer it will be, yes, if you multiply by y inside, so y plus zy square by 4. So correct answer it will be option A. If the same question is asked for nominal T method, then as I told, for nominal T also A and D are equal, which is 1 plus zy by 2. Here B is z into bracket 1 plus zy by 4 and C is equal to y. So these are the ABCD parameters for nominal T method, nominal T method. Here it is asked for nominal pi method, so correct answer will be option A. So direct question will be asked based on ABCD parameters. I have also uploaded a video on derivation of ABCD parameters using different methods, short transmission, end condenser, nominal T and nominal pi. You can check out those videos. Question number 76. The radial distribution is simple and economical, but the reliability of the system is poor and leads to. Now the question is asked on a radial distribution. So in the case of radial distribution, if I draw the radial distribution, means this feeder is getting energized only from one end. That is nothing but the radial feeder. So this is the feeder and this feeder is getting supply only from one end, from this transformer. So this system is known as a radial system. In case of ring main system, every feeder will have more than one source. Here there is only one source. What is problem with this? This is a simple and economical. In India distribution system is mostly radial. Okay, almost 100% radial distribution system. Only in case of very important loads we can have a parallel feeder or ring main system, but mostly we have a radial system. What is the problem with this is that it leads to evacuating of energy supply if there is fault in the line. That is not correct. Transmission of energy supply if there is a fault, which is also not correct. If there is a fault in this system, so it's breaker and relay, so this will open. So whenever there is a fault, that protection system will operate and there will not be any supply, there will be interruption. So transmission of energy supply if there is a fault, so that is also not correct. Distribution of energy supply if there is a fault, that is also not correct. Interruption of energy supply if there is a fault, so that is the correct answer. So whenever we use the radial feeder and if fault takes place on that feeder, then there will be complete interruption of energy supply from that feeder. Okay, so there can be many number of sections. There will be load on from each bus. So if there is a fault anywhere, main breaker will open and all the consumers, they will be disconnected. So that is the problem with a radial system. But advantage is that it's economical and it's a simple. The protection system is also simple and overall cost to design this system is less. Next question asked in Mahatransco AE exam 2022. Loop inductance in the form of GMR, geometric mean radius, is. Now what is the inductance of a single conductor? So it is 2 into 10 raised to minus 7 natural log D by R dash, Henry per meter per phase. So this is for one conductor, single conductor. Now what is R dash here? R dash is nothing but the GMR, which is given by 0.7788 R. So that is the inductance. 0.7788 R is nothing but the GMR. R dash. This is nothing but the GM. What is asked? Loop inductance. Now we know that if there is a single phase system like this, so one conductor will be phase, another will be neutral. So it will form a loop and both are identical. So therefore the loop inductance, it will be double that of the single conductor. So what we can write? So loop inductance, it will be equal to 4 into 10 raised to minus 7 ln d by r dash, that is d by 0.7788 r. So correct answer, it will be 4 into 10 raised to minus 7 ln d by r dash. So correct answer will be option B. So this is for a single conductor and this is for a loop inductance. Next question, 78, asked in GATE exam year 2003. The interrupting time of a circuit breaker is the period between the instant of. Now whenever fault take place, first relay will operate. So from the instant of taking the fault, so if we draw on a timeline, suppose here at this instant fault take place, so instant of fault, and at this instant on a time frame relay operates. Now what do you mean by relay operate? It will give commands to the trip circuit of a circuit breaker, or the trip circuit is closed, trip contacts are closed. So that is nothing but the operation of relay. So this particular time frame, so that is known as the relay time, operating time of a relay. Once circuit breaker contact get closed, after some time circuit breaker contact, it will be open. After receiving the trip command from the relay, it will take some time to open the circuit breaker contact. So this particular time duration, it will be known as circuit breaker opening time. So at this instant circuit breaker contacts are opened. Now we know that after opening the circuit breaker contact, there will be production of arc. After some time that arc will be extinguished. So at this instant arc is extinguished. So this particular time is the interrupting time, interruption time, circuit breaker interruption time, arc interruption time. Now these two, that is circuit breaker opening time plus circuit breaker interruption time, these two together will be called as a circuit breaker operating time. And what will be the fault clearing time? Fault clearing time will be this total, that is the at the instant fault take place till the arc is completely extinguished. So this particular time is known as fault clearing time. So fault clearing time is sum of relay time plus breaker time, and this breaker time is nothing but the opening time plus the circuit breaker interruption time. This is nothing but TC. So which option will be correct here? So initiation of short circuit and the arc extinction on an opening operation, that is not correct. Energizing of the trip circuit and the arc extinction on an opening operation, so this is the correct, because trip circuit is energized at this particular point and arc extinction, that is this particular. So this is nothing but the circuit breaker type. If you read third, initiation of short circuit and parting of primary arc contact, this it is not the breaker time. So energizing of trip circuit and parting of primary arc contact, so that is circuit breaker opening time. What is asked? The interrupting time of a circuit breaker. So this is nothing but the total interrupting time. So question number 79, ABCD parameters of short transmission line is. Now if you consider the ABCD parameter of a short transmission line, so this is Z, sending end voltage, load, Vs, this voltage is VR, Is and IR. Vs is equal to VR plus IR into Z if you apply the KVL here, and Is is equal to IR because there is no shunt path here. Is is equal to IR. So if you compare, so A is equal to 1, B is equal to Z, C is equal to 0 because there is no term of VR, and D is equal to 1. So 1Z01 will be the correct answer. 1Z01. Correct answer, it will be option D. Question number 80. For measuring positive, negative and zero sequence voltages in a system, the reference is taken as. Now we know that whenever we draw the positive and negative sequence networks, we take the reference as a neutral. Remember, for positive and negative, whenever we draw the circuit, we take neutral as a reference. Whereas for zero sequence, we take ground as a reference. For example, if I draw the positive sequence network of a generator, let us say. So this will be the positive sequence network of a generator. So this is the phase, this is the neutral. If I draw for the same negative sequence network, then we know that for negative sequence network there are no voltages. So again, this is the neutral phase. So this is the positive sequence network of a generator, three-phase generator delivering a current. This is a negative sequence network. Now zero sequence network, depending on the connection, if I assume that our generator is solidly grounded, then its network diagram will be something like this. So here we take this as a earth or ground, and this one is our phase. This is the zero sequence network. For positive and negative we take neutral as a reference, and for zero sequence network we take ground or earth as a reference. So the reference is taken as neutral of the system, not correct, because for zero sequence we take earth, ground only, that is also not correct, because ground we take for zero sequence, for positive and negative we take the neutral. So for zero sequence neutral and for positive and negative the ground, that is also not correct, because opposite is given. For positive and negative there should be neutral, and for zero sequence there should be earth. So correct answer will be option D, none of above. Thank you.